Welcome back to Mathematics 0110. I'm going to go through some very interesting types of examples that you hopefully find very helpful. First, weird example. We have f of x given to us as the ln of 4 plus g of x, and g of x is not given. So this may seem to be an impossible question. If we're asked for the derivative of something that we don't have, what are we supposed to do? Fortunately, the question is not asking for the derivative of that function in general. It's asking for the derivative of that function evaluated. And it's telling us what the g of x part is equal to at -3 and the derivative of g of x is equal to at -3. And that's all we're going to need to find the derivative of the overall function. I'll show you how to do this, and I'll show you how to do a whole bunch more that are similar. When we're taking the derivative of the ln of a function, we want to think about how to get access to rules like this. What is the derivative of the ln of w? Derivative of ln of w is w prime over w, no matter what w is equal to. So the first step is I want to make it look like that, so I'm just going to say everything in there, I'm going to label the 4 plus the g of x, I'm going to label all of that as w, and now take the derivative. Well, that's just w prime over w. What is w? W is equal to 4 plus g of x. What is w prime then? Well, the derivative of 4 is 0, and the derivative of g of x is g prime of x. So we just get g prime of x. And I'll substitute that in. G prime of x upstairs. And we have 4 plus g of x downstairs. Now we're going to plug in the data. We're going to say, okay, that's the derivative at x. I want the derivative at -3. And replace all the x's with -3. Okay, now what is g prime of -3? Well, the question says it's equal to -2. What is g of -3? The question says that that is 5. So we get -2 divided by 9. That's it. So it's very fast to do if you know what you're doing. Very impossible to do if you don't know what you're doing. Next question. This time we have a product of functions inside the log. And there's two ways to do this. The second way, which I'll let you discover for yourself if you're interested. It's slower though. I'm only going to show you the fastest way and the most efficient way to do this. The fastest way is to start the exact same way as before. Is to say everything inside the log function I'm going to call w. I'm going to write that derivative rule. Derivative of ln w is w prime divided by w. And then worry about the w stuff on the other side. W is equal to x times g of x. How do we take the derivative of x multiplied by g of x? That's a product of two functions, an a times a b. And the derivative of a times b requires the product rule. ab prime plus ba prime. A is x, b is g of x, so b prime is the derivative of g, which is g prime, plus b, g of x, multiplied by a prime. Well, if a is 1 times x, then the derivative of a is 1. And I'm going to transplant that in for w prime. I'm just not going to write the multiplication by 1, that's the only difference. And then divide by w, and w is x times g of x. At this step, you may be tempted to simplify by canceling things. That temptation is very bad. Please ignore it. Now plug in the data. Okay, so when we do this, we have to replace all of the x's by -3. In the last example, we didn't have x's all by themselves. We had x's plugged into g's and g primes, but here we have an x all by itself, so that one has to be replaced by -3 as well. -3 times g prime of -3 plus g of -3 divided by -3 times g of -3. You're going to have to yell at me in an email form or even video form. It doesn't matter. If I make any mistakes in these, I'll correct them. But I appreciate any corrections that you send my way. -3 multiplied by g prime. What is g prime? Well, the question says that g prime at negative 3 is negative 2, plus g of negative 3, the question says that that's 5, and then all divided by negative 3 multiplied by 5. Let's simplify. Negative 3 times negative 2 is 6. Negative 3 times 5 is negative 15. So this is going to be 11 on top, negative 15 on the bottom. We typically write that as negative 11 divided by 15, just moving the minus sign upstairs to put it into a standard type of form. So that'd be our answer. Next one, different, very different. It's not a log function, it's an exponential function. So what we have to think about is how to get access to this rule for derivatives of exponential functions. What is the derivative of e to the power of w? It's e to the w times w prime. So I'm going to start that way. I'm going to say that this is e to the w. I'm not really doing much. I'm just saying that g of x can be relabeled as w. Now take the derivative, just rewriting that rule, e to the w times w prime, and now we plug in the data. What is f prime of negative 3? So so this is e to the g of x times g prime of x. Now we can plug in the data, e to the g of negative 3 times g prime of negative 3. What is g of negative 3? It's 5. What is g prime of negative 3? It's negative 2. And then we would write this in standard form, negative 2 e to the power of 5. Keep in mind, just be cautious when you're reading this, that only the 5, or only the e, is raised to the power of 5. The negative 2 in front is not. If you wanted to raise both things to that power, you would need brackets around those two terms in front. So just be cautious when you're simplifying, not to break the rules of exponents. All right, next example is extremely similar to that one. We're going to start the same way. We're going to say that f of x is e to the power of w. This time our w is more complicated. Our derivative rule is not. It's just e to the w times w prime. W is equal to x times g of x. And we saw this already. How do we take the derivative of a term like this? And we have to use a product rule because it's a product of functions. It's an a multiplied by a b. So let's do that. W prime is going to be a b prime plus b a prime. A is x, b prime is g prime, plus b is g of x. A prime derivative of 1 times x is 1. I'm going to throw that in the formula with one exception. I'm just going to not throw in the multiplication by 1. Okay, w is x g of x. W prime is that mess of stuff I just found over there. X g prime of x plus g of x. And now we can plug in the data. So e to the negative 3 times g at negative 3 times negative 3 g prime of negative 3. You gotta be careful. Plus g at negative 3. Now, what is g of negative 3? It's 5. What is g prime of negative 3? It's negative 2. And then simplify. We get e to the negative 15 times negative 3 times negative 2, 6, plus 5. We can rewrite this as 11 e to the power of negative 15. Or, using some laws of exponents, we can write the negative power as a positive power in the denominator, 11 over e to the positive 15. So I'll circle both of them as good answers. They're both acceptable. Next question. Let's compare. Look at this one, the x g of x. The product is in the power. This next example, the x is not up in the exponent of the exponential function. It's outside the exponential function. So we cannot say that f of x is e to the power of w. F of x is equal to x times e to the power of w. I'll erase that because I don't want to confuse anyone. F of x is x times e to the g of x. I'm going to label the x as the a and the e to the g of x as the b. And I'm going to color code at this point. B is e to the power of g of x, which is e to the w. A is equal to x. Now, how do we take the derivative of a times b? It doesn't matter what we have for a, it doesn't matter what we have for b. We're always going to need a product rule. AB prime plus BA prime. A is x. B prime, I'm going to leave a box for that. It's going to need some space. Not much, but it'll need some space. B is e to the g of x. And then I'll leave a space for a prime. Okay, let's calculate all those quantities. If a is x, then a prime is 1. And if b is e to the power of w, then what is b prime going to be? It's e to the w times w prime, which is e to the g of x times g prime. Okay, so I'll just put that in the box over there, and I'll put the 1 in the box over here. Now what do? We have two options. We can common factor the e to the g of x out and then evaluate, or we can just evaluate. I'm just going to evaluate. I don't want to fuss around with this. Lucky I said fuss. E to the g of x, this is supposed to be pg, so e to the g of negative 3 times g prime of negative 3 plus e to the g of negative 3. We don't need to have that multiplication by 1 anymore. Now plug in the data from the function, from the question. Negative 3 e to the g at negative 3 is 5 times g prime at negative 3 is negative 2 plus e to the power of 5. We have so in that first term, the negative 3 times e to the 5 times the negative 2, we have three things multiplied together. We can combine the first thing and the last thing using, using the law of exponents. If you have a to the m times b to the m, so the powers match, you can write it as a times b all to the power of m. Negative 3 is raised to the power of 1. Negative 2 is raised to the power of 1. We can multiply them together and get something negative 3 times negative 2. So 6 raised to the power of 1, so just 6. E to the power of 5. We can't bring that 6 into the base e. The base e is raised to the power of 5 and the 6 is not, so we can't combine them. We have 6 e to the 5 plus 1 times e to the 5. So 6 cookies plus 1 cookie is 7 cookies, 7 e to the power of 5. And that's it. Next one. The structure of this question is almost identical to the previous one. The previous one we had a function multiplied by e to the power of something. This one we have a function multiplied by e to the power of something. Just the somethings are different. I'm going to start by rewriting the question. One common email request is, not request, but inquiry is, why do you rewrite the function? Do you have to rewrite the function? I rewrite the function because it helps me make sure I don't miss anything. It's a memory tool for not missing things and not forgetting things. It helps you cut down errors. I'm going to call x plus 6a. I'm going to call e to the e2g of x, and I'll call that b. So the most important thing to recognize in this example is that this is a product rule, and we have to start that way. So f prime of x is ab prime plus ba prime. I'll leave some spaces for things. We have x plus 6 for the b prime, for a. I'll leave a big box for b prime. Plus b is e to the 2g of x. And I'll leave a smaller box for a prime, just look based on what a prime is equal to. A is equal to x plus 6, and that means a prime is equal to 1. So I'll throw that in right away. we have to spend a little bit more time on b. b is equal to e to the power of 2gx. This is e to the power of w. Just always use this trick. Take something that looks messy, replace it with something that's less messy. Think about what derivative rule applies. Derivative of e to the w is e to the w times w prime. Same as the last example. 2g of x. Now what's the derivative of 2 times g of x? Well, it's just 2 times g prime. Think about your implicit differentiation. What's the derivative of 2y? 2y prime. What's the derivative of 2g? 2g prime. What's the derivative of 2x? Not 2x prime. Well, it is. It's just 2. And that's because the derivative of x with respect to x is 1. All these things are connected. The implicit differentiation and the chain rule are the same thing. And this statement, this e to the w prime, that's just a special type of chain rule. Anyway, I'll plug that in over here. E to the 2g of x times 2g prime of x. And now we're at the point where we can plug in -3 for x everywhere. So we get -3 plus 6 times e to the 2g at -3 times 2g prime of -3 plus e to the 2g at -3. Now plug in the data for those things. Well, okay, not data, but -3 plus 6 is 3. And we have e to the 2 times 5 times 2 times -2 plus e to the 2 times 5, and then we can simplify. We have 3 constants in the first term that we can multiply together. 3 times 2 times -2, so -12 e to the power of 10 plus 1 times e to the power of 10, so -12 cookies plus 1 cookie is -11 cookies. I don't even know what -11 cookies means, but it doesn't matter because it's math. Bob buys 60 watermelons. Henry buys 80 watermelons. How many do they buy together? Only in math we buy that many watermelons. All right, so let's compare. Oh, this is just the same question. Oops. Anyway, copied it by accident. Next one is horrible looking. We're asked to find the derivative. Same data about g, same data about g prime, but f of x looks brutal. Well, what do we do when the function looks brutal is we think about how can we represent it in a simpler way. And I'm going to do the same thing as always. I'm going to call everything in there the 4 plus the 4g of x. I'm just going to give it a name. I'm going to call it w. W is 4 plus 4g of x. So I can rewrite f of x as 3 times the ln of w. When we take the derivative, the 3 weights outside multiplies by the derivative of ln w, which is w prime over w, so it's just 3 w prime over w. And then we'll plug in what we have for that. I have a box for w prime. Well, we may not need that much space. And then w is 4 plus 4g of x. Let's find w prime. Derivative of 4 is 0. Derivative of 4g is 4g prime. So this is just 4g prime. And we're now at the stage where we can plug in the data. F prime of -3 is equal to 3 times 4 times g prime of -3 divided by 4 plus 4g of 3, or -3 rather. So we have 12 times g prime of -3 is -2. 4 plus 4 times 5. Well, this is going to work out nicely. -24 divided by 4 plus 20, positive 24. This was an accident. I didn't actually cook this one to be beautiful, but it is beautiful. Magnifique. That's the answer. All right. So look at the comparison between these two. I've made the next one, the function, simpler, but asked for something mean. This is extra mean. This is cruelty plus. We're asking for the second derivative of this function that involves data. And actually, it's worse than cruelty plus because I've now realized I did not give you enough data. You need one more piece of data. Also, told that we need g double prime at -3. And I'll say it's equal to -1. I'm just the question as originally written was defective. I have to add this in or we can't do anything. Okay, so I'm going to take this 4 plus g of x, I'm going to call it w. Prime. All these videos this week are over 30 minutes, or over 20 minutes each. They're all like 30 something. Sorry about that. Okay, so this is ln w for f prime of x. The derivative of ln of w is w prime divided by w. I'm going to write w off to the side. W is 4 plus g of x. Did I screw something up in the last one? Let me double check something. No. Okay, I left the 4. Good, 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 good. Good, good. So w prime is 0 plus g prime, which is just g prime. So g prime of x divided by 4 plus g of x. Now we have the bad part. We cannot plug in the data right now. What we have to do is take the second derivative. But how? How do I take the derivative of that? What rule do I use? And it is one of your favorites. It is the quotient rule for a top function over a bottom function. At least I think it's one of your favorites. So bt prime minus tb prime all over b squared. Bottom function is 4 plus g of x times t prime, so leave a space for that, minus t, which is g prime of x. I'll leave a space for b prime, all divided by the bottom squared, 4 plus g of x all squared. We're going to have to calculate those quantities. T is equal to g prime of x. So t prime is the derivative of g prime, which is g double prime. So g double prime of x goes there. And then b is 4 plus g of x. B prime is going to be 0 plus g prime of x, which is just g prime of x. Now we can plug in the data. We're going to get 4 plus g. I'm going to just plug in, I'm running out of space, so I'm just going to plug in what g at -3 is. G of -3 is 5. Times g double prime at -3, which is -1, minus g prime at -3 is -2, g prime at -3 is -2, and then all divided by 4 plus g at -3 is 5, all squared. Now simplify. 4 plus 5, 9, times -1, -9. Now we have negative, 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 so -4 divided by 4 plus 5 squared, so 9 squared. We get -13 divided by 81. That's our beautiful answer. That's it. See you next time.